yesterday with actual type of a question that will be asked in an exam. So I came across this one somewhere. It says a ball of 5 kg mass is dropped from a height of a building which is 7.06 meters above the ground. It is okay. It hits the ground and bounces reaches the height of 3.14 meters after the first bounce. Yes. After the first bounce. A lot and lots of questions will come from this one. But the easiest one to pick up is, are we in a position to actually draw a trajectory for this particular problem? Bounces after the first bounce, full stop. This is just a statement, no diagram, nothing. Can we be in a position of drawing the trajectory or the sketch that illustrates exactly what is happening in this particular problem? Ladies and gentlemen, it is easy to say the sketch should tell us that this is our building. Let's make it in yellow. And this is our ground. And I can easily label everything. This is now ground. What is the examiners telling me? I have a ball with a mass of 5 kg. It is dropped from a certain height of 0.76. From there to here, we have 7.06. It hits the ground. So it hits the ground and bounces, and then it bounces. Reaches the height of 3.14. So when it has bounced, it reaches a ground above the ground 3.4. Ponzo, what is missing in this diagram of mine? It is the trajectory, it's everything, it's nice, it is the information given, but there's something missing, and it's something that is very, very important for us. What is missing there?
Sir,
Yes.
I am not quite sure,
Say,
but it is
yes.
the labeling, I think.
Labeling. It is A. It is correct. It is the labeling that is missing, because the labeling will assist me with where am I in my projectile motion. So the labeling is very, very important. And VC, something is also missing. What could it be?
Says it
Gravitational force.
It is just the choice of direction. We are choosing now downward as positive. It is as simple as it gets, ladies and gentlemen. Why this simple diagram? AB, we know what to do because the information there, it says it is dropped. V initial there is equals to 0. We already know at maximum height V is equals to 0. Why? Maximum height. Already that information is what I must know. Let's read the first question. The first question says calculate the velocity. Calculate the velocity at which the ball hits the ground. Your Excellency, in which motion or part of the motion should I be considering for this particular question?
So the downward motion, the downward uh wave.
You are saying the downward motion. True. That is the reason why my first question for Ponto was what is missing. Ponto said labels. So I must be in a position to just say from A to B. It makes my life easy. I know which motion I am focusing on. So I am just going to write here to say I am looking in the motion of A to B. And that makes my life very, very easy and simple to actually comprehend and understand. So I'm just going to say from A to B. What do I have? V initially 0, G 9.8 meters per second squared. Do I have delta Y? Yes, it is given 7.6 meters. Then the correct equation here, Vf squared, V initial squared plus 2G delta Y. And we want V final. I know this one is 0 squared plus 2 multiplied by 9.8 delta y 7.06. Everything is positive because we agreed to say positive downwards. Then the final answer, ladies and gentlemen, is 11.76 meters per second. It's as simple as that. Simple as that. At number B, they say now calculate the time taken to hit the ground. Calculate time taken to hit the ground. VC, which motion should I be looking into?
Is it A to B, sir?
A to B, thank you very much. I am also looking from A to B. The information basically, it is still now the same. And if it is the same, I can just easily say delta y is equals to VIT plus half GT squared. What do I know? VI0T plus half of 9.8 T squared. This is 7.06. After doing the mathematics, you find that everything is T is equals to 1.20 seconds. Please verify my mathematics, but I believe everything should be correct. It's as simple as that. So I am not complicating the science. I am just making you aware of how you can play around with all these things. Can you use an equation that has time, V final, V initial plus GT. Let's maybe confirm with this one. We agreed our V final is 11,76 VI 0 plus 9.8 T. Let me quickly take my calculator and just press these values and just check, just to confirm. 11,76 divided by 9,8 is giving me exactly T is equals to 1,2 seconds. Where am I from A to B still? So if I am in that region and using the correct data, ladies and gentlemen, there's no way I can get this thing wrong. This is my way to that distinction that we want. This is our way of comfortable level 7. Why, ladies and gentlemen? Because I am not moving around as if I don't know what to do. So the strategy of the trajectory, believe you me, is working 100,000%. Why? Because of I know exactly where I am in the motion of the projectile. Ladies and gentlemen, calculate the velocity at which it leaves the ground. ABC. Calculate the velocity at which it leaves the ground. Your Excellency, which coordinates or points should I be using or considering? Calculate. Yes, Your Excellency.
B2C, sir.
B2C. Now, can you see how important that is? It is important because at least now we can at which it leaves the ground. So from B to C, let's write our data. Very easy. We want V initial at B. That is the question. Do we have V at C? Yes, V final is equals to 0 at C, Y, written maximum height. What else is given? Delta Y is given 314 meters. What else do we have? We have G, which is equals to 9.8 meters per second squared, which is now just our easy, nice constant. Let's check what are they asking us. V initial. So the equation that I must use, sorry about that. It seems like I lost you for a couple of minutes. VC, are you still there?
Yes, sir.
Thank you very much. Ponzo?
Yes, sir.
Thank you very much. Your Excellency?
Yes, sir.
Thank you very much. Now, ladies and gentlemen, we said we are taking downward as positive. So it means everything that is going down in this instance must be negative. So the correct equation is Vf squared is equals to Vi squared plus 2g delta y. V final 0. V initial, it is the question, plus 2 multiplied by minus 9.8 minus 9.8 and 3,14. And when you are done with the mathematics, the initial is something like 7,85 meters per second. It's as simple as that, ladies and gentlemen. It is as simple as that. Yes, VC.
So why is the 9,8 negative?
Because remember, lady, we chose our direction to say, oh, sorry, it must be positive. Thank you, VC. It must be positive because it is also going down. Positive, and this one must be now negative. Delta Y must be negative. Let me maybe move it here so that I can get enough space. Thank you very much, VC. Then we just say this one is 9.8 positive because G is down, but it's going to cover the distance upward. So 314 must be negative. Then you will still get the same answer. Thank you very much, Vimbai. Happy?
Yes, sir.
Thank you very much. Thank you very much. Now, ladies and gentlemen, the question is calculate the net force. A, B, C, D. Calculate the net force. And I believe that will be the last thing to do. Calculate the net force at D. Calculate the net force at which the ball hits the ground. Maybe I must just duplicate. I must just quickly duplicate. How do we go about this one, Your Excellency?
So you can use F net equals to MA.
F net is equals to MA. We'll check. F net is equal. That is second law, ne? The only force
Yes.
acting is force of gravity. Okay, but now we have the mass of 5 kg. What will be the acceleration?
9,8, sir.
9,8. That will not be correct because that A of Newton's second law, it is the acceleration of an object when it is moving horizontally. So it is
What about impulse?
okay. My question was, is it a collision between the ball and the ground? Yes or no?
Yes, sir.
If it is a
Yes,
collision,
sir.
then we don't worry about Newton's second law. We worry about impulse because impulse and conservation of linear momentum are the ones that are assisting us to actually focus now on what? On the collision. Hence, I said here to say we are going to have integration of topics. And this integration of topics is important because the assumption is by now you have done momentum and impulse. Very, 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 very important. I must also add the ball, full stop. The ball is in contact with the ground for 0.01 seconds. So can I write down my data? Okay, let's say I need to understand where am I. VC, which one will be able to assist me to answer here? Because it says calculate the net force at which the ball hits the ground. So where am I in my trajectory?
Is it from A to B?
From A to B. From A to B. So already, ladies and gentlemen, already Ponzo, I will not be writing down the data that is out of what the examiners are asking. So I stand a better chance of getting it correct. Why do I stand a better chance? Because I know what is it that is going to assist me to actually get to the correct answer. So I'm going to write my data. Fnet is the question. Time is given 0.05 or 0.1, sorry. What else is given? I have mass. And because Mr. Ditabe told us to say this is a collision, and we did momentum in detail, and we are working with one object, then it means it must be impulse and then mass 5 kg, but it says Fnet multiplied by changing T is equals to changing P. M V final minus V initial. Now, Mr. Ditabe, what is my V final? What is my V initial?
The V final, according to the calculations, it was 11.76.
It was 7 point. Or was it 11?
Yes, sir.
Okay, yes. EV in 11,78. Thank you very much. V final?
No, sir. V final was 11.76.
Okay. V final 11,76 meters per second. And V initial?
It's 0, sir.
0. Because we are looking at A, B. Thank you very much. Then it means what else? T 0.01. Fair. And I have everything that I need there. I have everything that I need, which is just Fnet multiplied by 0.01. Please help me with your calculators. 511,76 downward minus 0. So you do Fnet is equals to 511,76 divided by 0.01. Then you get your answer in Newton. Simple as that. Simple as that, ladies and gentlemen. And that is basically it with now the bouncing ball. Ladies and gentlemen, remember this session should be short I have questions here. Two ball situation. Yes, VC.
So I just wanted to ask about the SI unit. Since we're calculating impulse, but it's not a momentum and impulse topic, do we just say newtons instead of newtons per second?
No, the question wanted the net force. Remember, for it to be impulse, it means it must be F net and time. Then it will be Newton second. But in this instance, it says calculate the net force because the time was given as 0,01. So the time is there. We have the time. So we are not calculating impulse. We are actually calculating the F net. Do you follow?
Okay, thank you.
Yes, it was.
Yes.
If the question was uh, impulse, then it means time will not be given. Then we will get F net multiplied by T, which is an impulse. Then it will be Newton second. Thank you very much. So as I was saying, ladies and gentlemen, I have this question 5. It is a two ball situation, and question 6 also two ball situation. And this, if time allows, we will discuss on Friday 6 o'clock. The reason for that is I want everybody to be here because remember, most people complain to say we don't understand this thing of two ball problem. So I chose this. My thinking was we will be able to do them. However, let's pause, save everything, and say it is exactly 2029. So we have worked for the day, and let's meet again on Friday 6 o'clock. I will try to compress everything and maybe introduce organic chemistry as well, so that we can be able to finish on time. Ladies and gentlemen, I will not send these e-notes today. I will send them, I will just check. I will most probably send them tomorrow morning. I want to modify a few things, but if I can do it now, I will definitely do so. So ladies and gentlemen, that's basically it for today. And yes, I think we have covered enough ground in terms of the bouncing ball. Ratanang Phehlo, welcome, welcome. We understand there's a lot of things happening, but however, you will get the e-notes. Please go through them, and we will continue with these two questions here. Question 5 and question 6. These are now two ball situations where majority of us we agreed to say we have now few challenges thereof, so that will be attended to that. Ladies and gentlemen, with that being said, from me to you, thank you very much. No reflections today. We will do the reflections on Friday, and thank you very much and all the best for your rest of the week.